So welcome back. We have been discussing on the classification, the criteria of classification. Okay, and we saw that the classification must be based on phylogeny. It should include the phylogenetic studies. And while taking up the phylogenetic studies, the homologies and the analogies have to be taken care. Okay, so the next one we have is the plesiomorphic. So the study of homologies in classification must take into account two features, that is plesiomorphic as well as epomorphic. Okay, so we saw that there was a ancestor in the past which had all the characters of a vertebrate, that is a vertebral column, and they had all the characters of chordata. And from that particular ancestor arose a group of those members of that particular ancestral stock. It gave rise to the species, which include all the fishes. Okay. Then later, a few of the members of that particular ancestor slowly developed four legs during the course of evolution. It took maybe millions of years, but it evolved four legs. Okay, developed four legs on the course of evolution, and those groups later it gave rise to the amphibians. Fine, and these, but some of them uh, with the four legs, uh, it gave rise to a group of organisms which could develop amniotic. Okay, amniotic in the sense like egg, which is having the yolk and all those features which can support the embryonic development inside the shelled egg. Okay, so that is amniotic. And these ancestors with four legs and amniotic slowly started to evolve. Okay, at a point of evolution, it gave rise to the reptiles. Okay, some of them it slowly developed hairs and mammary glands, and then it developed into an ancestor. And this ancestor, a few of the members, it later evolved slowly into the platypus. Okay, monotremes we call egg-laying mammals, isn't it? Later on, few of the what you call ancestors, it developed the ability to give birth to young ones. Okay, and it is the major what you call as placental mammals, right? So when we study the evolution of placental mammals, okay, from the perspective of the placental mammals, when we look into the phylogeny, we can see that the development of four legs is actually a very early development, a trait which was developed very early. Okay, such kind of characters, it is known as plesiomorphic, which we refer as plesiomorphic or the primitive characters. Okay, what about taking up the or developing the ability to give birth to young ones, that is vivipary. Okay, with respect to the placental mammals, vivipary is a very advanced or very recent development. So those kind of recent characters develop. It is known as the epomorphic characters. So I hope it is clear. That is primitive characters. It is the plesiomorphic characters, while epomorphic characters, it is otherwise referred as derived characters. Okay, epomorphic characters can be found only in a very few groups of animals because it is actually very recent development of a character in the course of evolution, while plesiomorphic or primitive character can be seen in many group of organisms at the same time. Okay, so this also have to be studied because when we are taking up an epomorphic character, obviously those groups with epomorphic characters will be very closely related as compared with those groups with the plesiomorphic character. Okay, so when we speak about placental mammals, the fishes and the placental mammals, they are related but not so closely related. Okay, so that is what we classification should include even the study of the plesiomorphic as well as derived characters. Okay, now it should be based on a combination of characters. Classification, scientific classification should not be based on a single one or two characters alone, but it should be based on a combination of characters. It should include many characters at the same time rather than a single character, because if it is based on a single character, it can result in classification that is actually erroneous. Okay, then next one is it should be simple and stable. It should be simple in the sense it should be understandable. The classification should be understandable by any person, any layman. Okay, but it should be stable. To some extent, it should be stable as far as possible, but it cannot be stable every time. The reason is, in the sense, sorry, not stable, it cannot be static every time, because every day there are plenty of animals getting discovered, new species are getting discovered. So when you are including these species, obviously the classification may have to get modified accordingly. So what happens, it cannot remain entirely static, it has to be modified with respect to the addition of new species getting discovered. Okay, even so, what happens is when deeper studies are carried on the already discovered species, we come to know that that particular species should not have been included in a particular taxa, but instead it should be included in some other taxa. Okay, so in that case, if when new data, when new information about already discovered species comes into picture, we may have to modify the classification based on that. Okay, so earlier when we were studying, there is a species known as peripatus. Okay, peripatus, it was considered to be a part of annelids. Okay, earlier, uh, um, they were grouped into some other phyla, but now it has been taken out of that phylum, and then it has been kept separate as a under separate phylum, which is known as a Onychophora. So again, that kind of a modification is happening. Classification modifications of classification is happening based upon new data and new information coming up through deeper studies. Okay, so this is with respect to the criteria of classification. Okay, now I hope it is clear. That is, it should be based on phylogeny. When we are studying the phylogeny, it should include homologies and analogies. It should include plesiomorphic and apomorphic characters. Okay, and it should not be based on a single character. Instead, it should be on the basis of a combination of many characters. It should be simple and stable so that it can be understandable by anyone, and based upon new additions, new discoveries, and new information from deeper studies of already existing species, the classification must be modified. It should not be entirely static. Okay, so these are the few criteria upon which the classification has to be made. Now there is another concept known as splitting and lumping. Okay, I suppose you know about euglena. Okay, euglena. Obviously, earlier when we studied plants and animals, how we differentiate. Obviously, plants can photosynthesize, while animals, they don't have a chloroplast. They can move. That was a major character which were used for differentiating the animals from plants. But what about euglena? Euglena, it is moving. It do have flagella. They're aquatic in nature, but they do have chloroplast. Okay, such kind of organisms are considered to be borderline organisms. So where to be put? Okay, so there arises a question, such kind of organisms where we have to include in which taxa, okay, in which group, in which kingdom, maybe in the case of what you call euglena, in which what you call family. Such kind of confusions may arise. Okay, so there are two kinds of classification of borderline organisms where the borderline organisms may be included in already existing taxa. Such kind of inclusion, it is known as lumping. We just dump it all in already existing taxa, even though the particular species may show certain characters which are entirely unique, and it is not showing much of similarity with the members of the existing taxa. Still, we put it in the say existing taxa based on a few similar characters. Okay, now what about splitting? Splitting means we erect a completely new taxa, and then we include that borderline organism in that one. Instead of putting it in already existing taxa, we erect a new taxa. Okay, so that is known as splitting. So splitting and lumping, actually, lumping is the inclusion of borderline organisms in already existing taxa, and splitting, it is the inclusion of organisms of uncertain relations in separate or newly erected or established taxa. Okay, that is splitting and lumping. Okay. Now, what are the different systems of classification? There are different systems of classification. Not only these two, there are phylogenetic classification or evolutionary classification, but the ones which you are supposed to study is the artificial and natural classification. So, what is artificial classification? Artificial classification, it is a classification based on one or two characters. Okay, it needn't include more. For example, if you are classifying animals based upon the habit and habitat, what happens is um, dolphins, whales, uh, walruses, seals, jellyfishes, fishes all may come into the same group. But you already know that fishes, comes under species. Obviously, whales, dolphins, etc. comes under mammals. What about jellyfishes? They are completely invertebrates, isn't it? So, it is actually artificial classification. It is based upon one or two morphological characters, and it was actually the classification based on maybe like morphology, maybe habits or habitat, mode of life, etc. Okay, and it was adopted by the early systematists. Okay, those working in the field of systematics in the early period of the biology. It is a history of biology. We can see that they were actually more taking up the artificial kind of classification. Okay, and the classification of animals into aquatic, terrestrial, arboreal, aerial, etc. It is an example of artificial classification based upon the habitat. Then based herbivores and carnivores based on the habit. Maybe oviparous and viviparous, again it is with respect to the so these are the few examples of artificial mode of classification, and they give no information about the relationship or phylogeny. Obviously they don't even take up the phylogenetic data for classification, so they don't give any picture on relationships, interrelationships or phylogenetic relationships. And often this kind of a classification results in grouping of unrelated organisms in the same group, and related organisms get separated into different groups. So such kind of error happens during the artificial system of classification. Okay, and this was followed during the early period of like systematics, and the major proponents were Theophrastus, Pliny, etc. Okay, natural system of classification is a type of mode of classification which includes or which is based on uh, different characters like morphology, anatomy, physiology, ethology, that is behavior, then phylogeny, to some extent, not completely. Physiology, every such kind of characters, features are included for the classification. They never use habit and habitat for as a criteria for classification, and the natural system of classification gives information on both the interrelationships as well as the phylogenetic relationships. Okay, and this kind of a classification was actually accepted by or used by John Ray and Bentham Hooker. Bentham Hooker is the one who classified plants, and it is even now, I suppose, widely accepted. Okay, and this gives a it is actually this one kind of widely accepted system of classification. Okay, so these two are the main mode of systems of classification. So we saw the different criteria for classification. We saw lumping and splitting for classifying organisms, and the systems of classification. So what is the significance of classification? Why do we need to classify organisms? Obviously, classification provides simple scientific system of grouping and naming organisms. So it will be easy for us to study. For example, if you're studying birds, okay, we can't study the characters of all the birds existing on the earth, so as to complete the study of birds. Okay, if you are studying the, just imagine nervous system of birds, how it functions, what are the structure. Obviously we can't take every individual bird to study. Instead, what we do, we may take a single bird and we say that okay, this is the character shown by all the birds. Obviously this kind of a grouping will help in this study as well. Okay, so provide scientific system of grouping and naming organisms, and it also provides a convenient organization of living and fossil organisms. Okay, reveals phylogenetic relationships, and it is a tool for analysis and study of diversity. So when we when we have to group organisms, we have to identify them, we have to name them, then only we can go for grouping. isn't it? When we name the organism, we will come to know how many organisms or how many kind of species are existing on the earth. That is how the study of biodiversity is taken up. Okay. Similarly, unless we know what all kinds of organisms are existing on the earth, we cannot conserve them. So it also helps in conservation of biodiversity. Okay. So thank you.